This is the next thing. The point M. This is how we locate the point M. We use the coordinate x, x, y, comma, z. Okay. So, but here you have to get used to writing x in the direction of E plus y in the direction of G plus z in the direction of K. This is how you locate the point M in space. Okay, in the Cartesian coordinate system. So the only question that they are going to ask you is donner la vitesse de déplacement et accélération de la base cartesienne. That's the only question that they're going to give you. That's the only thing. So you construct everything on your own. So then vector vitesse. Okay, so this is the notation. You might have different notations, but the view will always be there. So the vector vitesse of the point M in R is the reference system. So the reference system in the Cartesian coordinate system is 0, which is the origin, E, G, and K. Then people from our CIMA, I was reading a book from our CIMA, so you'll be using UX, UI. I have not received the book from Agadia yet, so this is the notation unit. These are the unit vectors that you'll be using, but people are going to our CIMA. Instead of EG, you'll be using UX, UI, UZ. So it's just the notation, okay? Everything else is the same. So this is, you find the derivative of OM with respect to time, then you specify in what? In R. That is in the Cartesian coordinate reference system. So when you say in R, for Cornelius who has just joined us, so this notation, when you say in R, you mean E, G, and K are constant. So whenever you put the reference system where you find the derivative in, it means that E, G, and K are going to be constant. So what are you going to do here? Here, instead of applying the product rule, you are only going to be concerned with this part. This part, you know that you should find the derivative of this part, keeping the other part constant. This is going to be 0. So you don't even waste time applying the whole product rule. So here, you're just going to apply the product rule to the first part, where you're going to find the derivative of, first let me put the derivative of everything is xe plus yg. This is mécanique du point now, plus zd k. Okay, with respect to time. Then in R, we just simply mean E, G, and K are constant. R represents the reference system, which is the Cartesian that we are using here. So then you derivate each component. So it's a product, but you're not going to apply the product rule because you're derivating in R, which implies that E, G, and K are constant. So you just find the derivative of x with respect to time, then keeping E constant. You're not going to find the other derivative, then plus the derivative of y with respect to t, keeping G constant, then plus the derivative of z with respect to t, keeping K constant. Okay? Now, the derivative of x is x, y, and z. These are coordinates that are always changing with time. Someone wants to join. So x, y, and z, these are coordinates. So the point M, depending on where the point M is, so after a certain period of time, this is why you should imagine x, y, and z as functions of time. Okay, because they change with the time. Okay, so the derivative of x with respect to time is, what did I say when you find the derivative with respect to time? There's a special notation, x point. We say x point in French, e direction plus y point, g direction plus z point, k direction. Then you found your velocity or vitesse of the point M in R. Okay, then from our CIMA, you're going to be using x point ux plus y point uy, then plus z point k. Uz, unit vector in the direction of z. So instead of using e, g, k, you're going to be using ux, uy, and uz. Or some people use x point ex plus y point ey plus z power z. As simple as this. This is how you find the vector vitesse in Cartesian. Okay. So now the next question that they'll ask you is the acceleration. Okay. Acceleration. Okay. So acceleration, the notation for Cornelius who has just joined us, we no longer use A for acceleration, we use gamma. I don't know if this is gamma. Gamma, yeah. The acceleration of the point M in R is equal to um, you you find the derivative of your what you found the vitesse with respect to time, okay, which is equal to acceleration is the same as the no let me not confuse you with the double derivative, the second derivative I mean. So in short, you just find the derivative of what you just from finding x power ex plus y power ey plus z power. Please watch the coordinate systems. They're going to help you a lot in R. So you know that ex, which is the same as e, g, and k, they are what in R? They are unit vectors of R, so they are fixed. So what are you going to do? The product true, you are only going to find the first part of the product true. So the derivative of x power with respect to time, ex keeping ex constant, plus the derivative of y power with respect to time, keeping ey constant, plus the derivative of z power keeping ez constant with respect to time. Okay. So now, if I were to ask the question, what's the derivative of x power with respect to time? Who can guess? Then when you define it, what do you do? When you define velocity, you give us that expression, you interpolate it mathematically. The change in something over change in something is just the derivative. So dom over dt. Then this notation I said will tell you whether E, G, and K are constant or not. Okay. Then acceleration, you define acceleration, the change, oh, it's a change in velocity over change in time. Okay. Oh, so mathematically it's dv over dt. I said that whenever I write d of something, you're simply meaning the change in something for now. The small change in something specifically. Then, so this is what they have found. X d power e plus y d power g plus z d power k. The differentiation of everything with respect to time is you put a power on top. Now, they will rarely ask you about the base cartesian. It's just for you the basis. They will mostly examine you on the base cylindric. So for people who didn't do the base cylindric, you can watch the videos. But even here, don't worry. I'm just going to try to explain a little bit again. So I've overemphasized. Even you guys, you can see that okay, this guy has overemphasized on the base on the coordinate systems. So the coordinate system, for the cylindrical coordinate system, it uses rho, phi, the angle, rho, the radius rho, the angle phi, and then you define e rho for the people. E rho is a unit vector, just as x, y, and z had unit vectors. Okay, x had a unit vector e, x had a unit vector e, y had a unit vector g, and z had a unit vector k. Okay, so the unit vectors are there to show us the directions. Okay, so even rho, you give it a unit vector, so e rho. Okay, then it's always perpendicular. You define another vector if you have an exam after this week. Now next week, because this week you've got sports, next week on Friday you have an exam actually on the coordinate systems. It's going to be oral. I've not yet figured out how you'll be writing your exams online, but so it's going to be oral. Each one of you will be explaining to me how to construct all the coordinate systems. Okay, So make sure you watch the videos. That is going to help you to study, and 25% of 25% of your final note result is the quiz, the homeworks, and everything. So that quiz is part of the 25%. How you're going to explain to me, I'm going to give you a note which I won't disclose to you, just to help you understand the coordinate systems, because they are very important. So the coordinate system, the central coordinate system uses uh, rho, which is this one, then the angle phi, then with z, it uses the z-axis, the one from the Cartesian. So the only thing that you need to know is the unit vectors. So we define a unit vector in the direction of rho, which is e rho. Then this vector, if which is perpendicular to e rho, then you use the vector k, because the third vector is borrowed from the Cartesian. Okay, so how do you find OM in the Cartesian coordinate, in the pseudo coordinate system? You see, the only thing that you need to do is finding OM. So how do you find OM? So OM, you find OM as this is O, so you move ON plus NM. Why are you moving this? Why are you not going OM direct mass? So with a simple coordinate system, we don't go ON direct mass because we don't know the magnitude of this vector, and we also don't know the direction. So we are forced to move in an alternative route. So OM is equal to ON plus NM. I've explained how to find OM. So the only question that I'm going to ask you is determine le vecteur de position OM, le vecteur vitesse V et l'accélération gamma de la base cylindrique. That is how the exam, even the one that you're going to find, is going to come. So they expect you to know all the notations. Then from the people going to our CIMA, here use theta. So if you understand, you just be using different angles. Okay, where I was using phi, I'll be using theta. Okay. So guys, please watch those videos. Then on Friday you've got an exam, or exam expect you to explain to me these things, because you can agree with me that I've done my best to explain. Then so you find so what is your ON? ON will be ON is this is the vector rho magnitude, then e rho the unit vector to show direction. Then NM is parallel to the z-axis. So as we said, going upwards, the cylindrical coordinate system borrows from the Cartesian. So you just say plus, going upwards, you don't know how much you're going upwards, so you just z. Then in which direction? Direction of k, which they are found here. At the cylindrical coordinate system, OM ni rho, e rho plus z, ez, but it's better to know how to construct this, which is why I'm going to examine you on this one. Okay, yeah, so when you find OM to be rho, e rho plus z, ez, so for you to find the vitesse, same reasoning, you're going to differentiate OM with respect to time, then in r. Okay, when you're finding in r, for r we're talking about the Cartesian coordinate system EGK. So our reference system R usually is 0 EGK. What does this mean? This means that the only vectors that are fixed when we say in R, and we have this is our R, the only vectors that are fixed are EGK. So which means that the unit vectors E rho, E phi are not fixed. Only EZ is fixed. That is, only K is fixed. This is why it's important to also know the notation. Okay, so dollar base, yes. Do what you can to know how to find the OM in each base system. So but you just apply the same definition. So now you're going to differentiate rho, e rho plus zk, okay, with respect to time in r. So here's what you start identifying. Okay, in r, what is fixed in r? Is E fixed in r? No. So therefore, I'm going to apply the full product rule here. Is k fixed? Yes. So I'm only going to apply the partial product rule here. Okay. Those are the only things that you need to know. E row is not fixed in R. E row is not part of this vector, so it's not fixed. Only those that are part of them are fixed or constant. Okay. Then homework differentiate. So you differentiate each term. So we're going to start with D row E row. Okay. With respect to T in R. Okay. Now, if you followed nicely, even in the videos, I've mentioned that the derivative of a vector, if you want to know the derivative of E row, okay, the derivative of E row will give us a vector perpendicular to it, that is E phi, okay. So, therefore, this is what you know. The derivative of E row with respect to phi, the angle, is equal to E phi. This is a property of deriving a vector. Okay, so for people who are just joining us, every time E row, here's how you can memorize it. Okay, here's how you can memorize it. You have to know that row moves with the angle phi. Okay, then from row and phi, I'm going to have unit vectors E row and E phi. Right? So, and then these two unit vectors are perpendicular to each other. Okay, so if these two vectors are perpendicular to each other, you just need to know the parameters that you'll be working with. Okay, if these two vectors are perpendicular to each other, this one and this one, the derivative of one with respect to the phi, which row is associated with it, is equal to E phi. Okay, then if I go vice versa, if I start the derivative of E phi with respect to the angle phi associated to a row, will give me, of course, E row, but since I've changed the order, you just put negative E row. Here you said the derivative of E row with respect to phi is E phi. Then when you do a derivative of E phi, the derivative of this one with respect to this angle is equal to this. Then the derivative of this one with respect to this angle, since you're going in this direction, we just put a negative because we're dealing with vectors and direction matters very much. Okay, so going back here, so I told you that, so let me apply. This means that since this is fixed, I'm going to apply the product rule, and here's how we apply the product rule. So I'm going to say the derivative of row, the radius row with respect to time, keeping E row constant, okay, plus this time around you're going to keep row constant, then you're going to say the derivative of E row. Whenever you're differentiating a unit vector, you even specify, it's important to specify the reference system that you're differentiating that unit vector in. Here it wasn't even important because whatever reference system, this is not a unit vector. It's changing whatever reference system, but for the unit vectors, they change depending on the reference system. So from this reference system, R is usually this reference system. E row is not part of these vectors, therefore you define this is not constant, therefore this is not zero. E row is always changing. Okay, once you master these things, okay, now what's the difference? That's the derivative of row with respect to time. Anything with respect to time, you put row poor, then E row. Okay, plus now our main job is what's the derivative of E row with respect to time. I'm going to come back here. The derivative of E rho will give us a vector perpendicular to it. So therefore, the derivative of E rho is it with respect to time in R. Since E rho is not constant, so it's 0. Oh, it's not 0, it's not 0 in R. So it's going to give us a vector. Now, here's what I taught you again. If open ambish, that property is only applicable to the derivative of E rho with respect to phi, not time. So you convert this to you first write what you know. You know that the derivative of E rho with respect to phi is going to give me E phi. Then you multiply it with d phi over dt. So if you look at the left hand side and the right hand side, you find that they are equal. Why? Because here if I just cancel this and this, I'm going to remain with the E rho. The only difference that I've got, just to show that where you're differentiating from. So you're going to find that the E rho over dt, which is this side, right? So this is how you convert. This is how you use the chain rule. Okay, this is how you use the chain rule. Please, when you master those few things, for people who have been following, you know that rho, the derivative of E rho with respect to time is always what is the angle associated with rho or E rho? Phi power then E phi, which is the answer. But how are we finding phi point E phi? Let me remind you again. When you are differentiating E rho with respect to time, you say the derivative of what you know E rho with respect to phi, because you know that this is going to give you E phi. Okay, then you multiply by you complete the right hand side to be equal to the left hand side. So you say d phi over d time, so that when you cancel, you have the left hand side is equal to the right hand side. Okay, so you complete it. Well, how do you complete it? You should master this art of completing, because you're going to be using this, especially we're going to learn the fourth type of coordinate system, which is called the base de Frenet. But you have to learn base de Frenet when you understand fully these other coordinate system. So this art of completing is very important. It's very simple. Oh, I'm being asked, I'm going to repeat again because it's very important. I'm being asked to find the derivative of E rho with respect to time in R. Oh, what do I know? I know that whenever I differentiate E rho with respect to the angle phi, I'm going to get E phi, okay, which is a vector perpendicular to E rho. But I'm being asked to differentiate E rho with respect to time. So what am I going to do? This is what I'm going to do. I'm going to complete the right hand side such that it's equal to the left hand side. As simple as that. Then what is the derivative of rho of phi with respect to time? This is just nothing other than phi power. So this part will be equal to phi power. Then the derivative of E rho with respect to phi is equal to E phi. In general, whenever you have two vectors that are perpendicular to each other, these vectors that are perpendicular to each other, they always give the same answer. The derivative of this one with respect to the angle and not time. Therefore, you have to complete the right hand side so such that it's equal to the left hand side. So phi power E phi. Okay? Alright. If you have a question, stop me. Watch the coordinate system. I've explained all these. So this is why, coming back to it, it's very problematic. So this part, the derivative of E rho d time. With time, you're just going to be knowing that okay, in phi power E phi. But I don't want you to swat. So this is phi power E rho plus rho, which was constant, then df over dt, you apply a chain rule, which is completing the right hand side. So phi poa ifi. Are we clear on this one? So imagine if you're reading this book on your own. They give you OM, but in the meeting you can find you're teaching yourself. They give you OM, rho E rho plus Z E Z. You have to know how to find OM. Then vector vectors the poor M or R, dOM over dt in R is equals to, okay, then here you apply the product rule. Since E rho is non-constant in R. So you first find the derivative of rho with respect to time. You keep E rho constant, then plus you keep rho constant and you find the derivative of E rho with respect to time in R. Then plus you continue because there's this product, but you know at case, so you find the derivative of z with respect to time, keeping k constant, then plus z, the derivative of ez with respect to time, keeping r constant. But you know that ez or k is constant in R. Therefore, this derivative will be 0. But this derivative will give you something. So here they got rho point E rho, which is this. Then here it's rho multiplied by the derivative of E rho with respect to time is phi point. I've shown you how we got phi point if then plus z point is z. Are we clear? So therefore, this is how you find the vector vitesse. So it's going to be rho poa E rho plus rho phi poa E phi. Then the other one was just z poa k. Are we clear on how to find the vector vitesse? So alternatively, here's how you find the derivative of E rho, okay, with respect to time in R. So you first define your E rho. E rho, when you I know maybe you've forgotten, when you watch the coordinate system, we found E rho, expression of E rho to be cos phi E plus sin phi G. If you can remember the expression of E rho, then when you differentiate this side in R, it means that you're going to differentiate this side in R. Okay? Now, here's the thing. So we're going to differentiate this side. So for people just joined us, I said whenever you're differentiating sine, negative sine, this is just how you remember it. Maybe you never see this anywhere. So let's say if you're finding the derivative of sine, just go down. It's cos. Derivative of cos is negative sine. The derivative of negative sine, you go. This is clockwise, eh? A clockwise direction. Then if you're integrating my sine, you just go downwards. So let us now. So this is how, instead of here, the answer is supposed to give us phi poa e phi. Okay. Now I'm going to show you that alternatively, if you don't know the art of completing the right hand side, I'm going to show you an alternative way of finding E rho using its definition in the Cartesian coordinate system. So we define E rho, we found it to be cos phi. When you watch the coordinate system, all these, now you are seeing the importance of coordinate system. At least I'm glad you are seeing it. This is an examinable question. So the derivative of E rho with respect to time in R is going to be, so you know that E and G are going to be fixed in R, okay, which is why R is here, okay. So which means that you're just going to partially apply the product rule, okay. So what is the derivative of cos? So you're finding a derivative with respect to what? Time. So what's it? So cos phi, the angle phi is changing with time. So the angle phi is changing, everything changes with time. The angles, all the parameters changes with time, okay? So the angle phi is a function of time, okay? So the angle phi is a function of time, okay? So now, this is a composite function. So what you do, you find the derivative of everything. If you remember the composites, what's the derivative of cos? You come to this diagram, the derivative of cos is negative sine, right? So you say negative sine phi. Since phi is a function of time, you just multiply by phi power. Okay, you apply the chain rule here. So, yeah, how can I explain this? So cos phi, phi is a function of time as well. So you first differentiate phi, which is phi power with respect to time. Then you multiply by the derivative of everything, which is sine phi. So you're going to have phi power sine phi, then plus, what's the derivative of sine? The derivative of sine is cos. So we're going to say cos phi in the direction of g. You're only going to apply, partially apply, then you're also not going to multiply by phi power, because phi is a function of time and you're differentiating with respect to time. So you multiply by phi power always. Then here I can factor out by phi power. Then I will remain with minus sine phi plus cos phi, the direction of E, the direction of G. So what am I going to have here? Here I'm going to have phi power. Then by definition we said this is E phi. We found E phi by differentiating this with respect to phi power. So if you are to differentiate this with respect to phi power, you're not going to multiply by, with respect to phi, you're not going to multiply by phi power. You only multiply by phi power because you're differentiating with respect to time. Okay, and phi is a function of time, so you multiply by, you apply the chain rule where you multiply by the derivative of what is inside somehow, so which is phi power. Okay, if you remember, yeah, so this is the equation for E phi. This is why we are finding E rho and E phi in the coordinate system, so therefore it has given us rho power E phi. But as you can see here, you have to remember the expression of E rho. You also have to remember the expression of E phi for you to find, just for you to find phi power E rho. It's a very tedious process. This is why I advise the students to just know this property, the art of completing the right hand side, applying the chain rule in short. So whenever I have the derivative of E rho, instead of using this definition expression, if you've forgotten the expression, just know that whenever I differentiate E rho with respect to the angle, which is phi, it will give me what? It will give me E phi. Okay, so I'm just going to complete this side D such that it's equal to this side and this side are equal. When I cancel side and this cancel side, I'm going to have the same thing. So now this expression I know it to be E phi multiplied by the derivative of this angle with respect to time is what? Phi power. Phi power is a change of angle, change of time. Then for people joined us in the first session, we said the change of angle with respect to the change in time, this is none other than angular velocity, or vitesse angulaire in French. If displacement over time will give us vitesse or velocity, then angle over time will give us angular velocity. So phi power is none other than the change of angle. Phi is an angle. Phi is an angle. The change of angle with respect to time, the derivative with respect to time, which is phi power, is the angular velocity and commonly denoted by omega. So omega is equals to phi power. You're going to be introduced omega kuntanshuku. So just know what angular velocity is a change, the rate at which the phi is changing at. So that is the change in phi over change in time, which is phi poor, the derivative. How many minutes am I remaining with?